All right, page 460 in your textbooks. And we just went over quizzes in here. Students did a great job on quiz 42, so proud of you for that. Homework over the weekend. We were working a little bit on word problems that had more than one unknown. Remember on the quiz, if there was something we didn't know, whether it was some number or how old some person was or whatever, we just called it B or X or Z or whatever number you happen to, or letter rather, you happen to choose. Right? But now we're going into problems where there's more than one variable. And so the key is to figure out where the comparison is, and whatever it comes back to at the end, that's the one that gets to be X or L or C or whatever letter you happen to pick. So on number one, though, here it's already kind of predetermined for us. I kind of already told you, if you see this, here's how we're going to represent it. Problem number one in the homework there on page 460, the sum of two consecutive odd numbers is 36. Well, class, when we count odd numbers, let's just start at 31, for instance. Say with me. 31, 33, 35, 37. Class, we're really counting by twos. We're starting at a rather random spot, but we're counting by twos, aren't we? 31, 33, 35, 37. We're counting by twos. Now, not in the way that we did when we were in kindergarten, okay? We're not counting even twos, right? But we're counting by two. We're adding two to every number. So I said then that if you have consecutive odd numbers, here we only have two of them, the first odd number and the second odd number. Well, you don't know what the first odd number is. So class, let's just call the first odd number X, for instance. But the next odd number has to be 2 greater. So the next odd number, class, would be X plus 2. The next consecutive odd number after that would be X plus 4, because you'd have to add another 2. And then after that, class, it would end up being X plus 6, because you'd then add another 2. Does that make sense? Now, let me give a clarification, okay? When you get to pre-algebra, I'm going to adjust how we count odd numbers. Because this assumes that you're starting with an odd number. But remember, X could be anything. What if it's not odd? Well, in these problems, it's going to work out okay? But there is a way to make sure it's rigged correctly. But for 7th graders, we're going to keep it a little bit simple here. We're just going to say, hey, odd numbers are spaced out every 2. Let's assume the first number really is odd, so then the next number would be X plus 2. And it says that the sum of these odd numbers is 36. Class, sum implies addition, right? We need to add these two numbers together. And if we do, it says it's going to be 36. So what should our equation be here, Joel?
X plus 2 equals 36.
Excellent. How many had the same equation? Or maybe you said, well, I already know I'm going to add X plus X, because you can't have multiple X's in the same equation. I know X plus X, class, is going to be 2X. So maybe you already started at 2X plus 2 equals 36. Did anyone start there? You said, well, I know the X plus X is going to add up to a 2X. Okay, a couple of you. I only did that once in class, so it wasn't something I was necessarily pushing you to do. At this point, we need to subtract away the 2 or put a negative 2 on both sides. That'll give us 2X, class, equals 34. And then when we divide away this 2 right here, we're going to get X is equal to 17. So it worked out correctly that the first odd number really was odd. It's 17. The next odd number is going to be 2 greater, class.
19.
And how many had 17 and 19 as your 2 odd numbers? All right, questions on this? Yes, ma'am.
Instead of for the first number and like put an X or X plus 2, I put X plus 3 and X plus 5. And
That worked, yeah. So her point was she used these. Now you overthought things a little, right? You made it a little more complicated than you had to, and your equation would have looked different. You'd have gotten 2X plus 8 equals 36, wouldn't you? And then when you subtracted the 8 to get 2X equals 28, you've got X equals 14. So well, that's not 17. No, but your first number was X plus 3, or 14 plus 3, which is 17. And then 14 plus 5 is 19. So your way works because they're still 2 apart. Do you see that? These are 2 apart, these are 2 apart, this way's just easier. Now, but not wrong at all to do it the way you did it. Yes, ma'am?
For the 2 numbers, I got 16.5 and 19.5. But like,
You didn't use this equation?
No.
What did you do?
It was 2X plus 3 equals 36.
Ah, so what were your 2 unknowns? X plus 1 and X plus 2?
Yeah.
Okay, well, in that case, do you see how they're only spaced out 1 apart? Odd numbers aren't spaced out 1 apart, they're spaced out 2 apart, right? So that's what threw you off. That's why she got away with doing it differently, because hers are still 2 apart from each other. But if yours are only 1 apart, it's not going to work. Does that make sense? Good. Any other questions? Great feedback. Any other questions, comments? All right, let's take a look at number 2. And this time, it's not consecutive odd numbers class, it's consecutive even numbers. For instance, let's just say we started at 44. Say them with me, class. 44, 46, 48, 50, 52. Class, we're still counting by 2s, right? So do you see that even if it's consecutive even numbers, I could still let my first even number class be x, because I don't know what it is, right? I don't know where to start. I picked 44 a second ago. I don't know where it's going to start, but my first even number could be whatever. The next even number, though, has to be 2 greater again. Does that make sense? So we should have had x and x plus 2. Again, whether it's consecutive even or consecutive odd, because they're spaced out by 2, this is how we represent them for now in 7th grade. All right, questions on that? So my equation then, it said the sum of these 2 consecutive even numbers is 90. How many had the equation x plus 2 equals 90 for this one here? All right, at this point again, we'll combine 2x plus 2 equals 90. We'll subtract the 2 to get 2x equals 88. And this is not a good choice by me a moment ago because x sure enough is class 44. That was not intentional for me to randomly pick 44 to start with. Maybe my brain had already solved it. I don't know. That'd be a little weird actually. But anyway, 44 is our first even number class, and the next even number is indeed 46. And there we go. An unfortunate place for me to use as an example a moment ago. How many got 44 and 46 as your 2 numbers? Okay, questions, comments on this one? Very, almost identical problems. It's just one ended up working out with odds, the other ended up working out with evens. Questions? All right, let's take a look at number 3. And I like this example a little bit better. Read number 3 for us, Michael.
The sum of 2 numbers is 15. One number is more than the other number. Find the number.
I think you must have missed something. Try that again.
One number is 3 more than the other number.
There we go. I bet you said one number is more than the other number. I'm like, there should have been something there. One number is 3 more than the other number. So once again, class, sit up, Caleb. I have 2 unknowns, right? I have some first number and I have some second number, but they're not necessarily consecutive, right? So it's not just x and x plus 1, x plus 2, x plus 3, or they're not consecutive even or odd where it's x plus 2, x plus 4. It just says one number is 3 more than the other number. Well, one of these 2 numbers, class, has got to be x, because I don't know either of them. Now, we can let Ben pick. Ben, do you want the first number to be x or the second number to be x? First number to be x. Okay, once you picked, and it doesn't matter which one you pick to be x, we just know this, that the other number, that one number, is going to be 3 more than the other one. So this, then, is going to be 3 more than that. Well, Ben, how would I say 3 more than that?
X times 3.
Not x times 3, that'd be 3 times this big. It's 3 more than. For instance, if I have 3 more pencils than you, I would just take however many you have and do what? Add 3. So in that case, the second number would have to be
X plus 3.
x plus 3. How many had either x plus 3 and x or x and x plus 3? Doesn't matter the order. Those were your 2 unknowns. X and x plus 3. And then it says that the first sentence, the number we haven't used yet, Corey, is 15. But it says what's 15? The first number or the second number? The sum of the 2 numbers. Okay, so Corey, what's my equation?
X plus 3 equals 15.
There we go. How many had this as your equation? X plus 3 equals 15. Does it make sense now if we didn't get it? All right, from here then we'll combine the x's, class.
2.
And you know what? What am I going to do with this plus 3 anyway? I'm going to put a minus 3, so why not do it now? Let's just get it out of the way. And get 2x equals, so that my x, when I divide both sides by 2, and I like to do that in my head, frankly, x ends up equaling 6. So one of my 2 numbers, the way we've got it set up, the first number, class, is 6. But the other number is 3 more than that. My other number would be 9. So either 6 and 9 or 9 and 6, depending on the order in which you did them. How many got those 2 numbers for number 3? All right, does it make sense now if we missed it? Again, we did not do nearly as much practice on Friday as I wanted to do. Questions? Yes, ma'am.
So, I had the wrong equation, but I still got
What was your equation?
I had 2 plus 2, no, that wasn't right. X plus 1 plus x plus 2 equals
So you had made it as if there were consecutive numbers, and you got x equals 6, right? But if your unknowns were x plus 1 and x plus 2, and you said that x equals 6, then your numbers should have been 7 and 8, not 6 and 9. Do you see that? So you made two wrongs. You represented incorrectly, and then instead of plugging the 6 in to get 7 and 8 as your answers, in this case we got 6 and 9 as our answers, you did a couple little mistakes there. Does that make sense? All right. Let's take a look at number 4 and read number 4 for us, if you would, Elaine.
Heather is 3 years older than Ashley. The sum of their ages is 29 years. How old are they?
How old are the girls? Okay, so how many unknowns do we have here, Elaine?
2.
And they are
Heather and Ashley.
Heather and Ashley. And we're looking for the comparison sentence. Ben, what sentence compares these two girls to each other?
Their ages.
So actually read the sentence that compares them.
Some of their ages is 29.
That doesn't really compare them. It does give me more information about their ages, but it doesn't compare them to each other. Which sentence compares them to each other?
Heather is 3 years older than Ashley.
Ah, there you go. Do you see how it compares the two girls one to the other? Now, who does it come back to in the end, class? Ashley. Heather is 3 years older than? Ashley. So who gets to be X? Ashley. Now you could represent Ashley something other than the letter X. I'm just going to go with X to be generic here. But if Heather is 3 years older, then Elaine, how do I represent Heather's age?
X plus 3.
X plus 3. How many had specifically, and this is the only way to do it, Heather as X plus 3, Ashley as X. All right, does it make sense now if we did not get that? Then we look for the number we ain't used yet, and that number, Elaine, is?
29.
And again, what does it tell me is 29?
The sum of their ages.
The sum of their ages. So what's our equation?
2x plus 3 equals 29.
Good. Rather than writing x plus 3 plus x, she knew the x's were going to combine anyway, so she said 2x plus 3 equals 29. From here, we'll subtract away the 3 class to get 2x equals
26.
26, and then we can divide both sides by 2 to get x is equal to
14.
13. All right, so here's the question, Elaine. We're not done because we have to tell how old these girls are. Who is 13, class?
Ashley.
Because Ashley's X is 13. Ashley's 13. Heather is 13 plus 3. X plus 3. So Heather, class, must be 16 years old. How many had a 16-year-old Heather and a 13-year-old Ashley? Okay, questions on this. Does it make sense now? Again, we're going to be practicing a lot more with this here in just a few moments. So if we missed it, don't beat yourself up, but learn from it. Questions? All right, let's look at the next one. Number 5. Read this for us, if you would, Griffin.
John bought 2 books at the used bookstore for $5. If the first book cost $2.50 more than the second book, what was the price of each book?
How many unknowns do we have here, Griffin?
2.
And they are the...
First book and second book.
Good, that's actually how it describes them too. It calls them first book and second book. So not being very creative myself, that's how I'm going to call them as well. Now, what's the comparison sentence, Bryson?
If the first book costs $2.50 more than the second book.
There we go. The first book costs $2.50 more than the second book. Okay, class, in that comparison, what does it come back to at the end?
The second.
So who gets to be X, class?
Second.
Second book. Griffin, how do we represent the first book then?
X plus $2.50.
Because it said the first book was $2.50 more than the second book, so we know it's going to be X plus $2.50. There we go. Now, what's the number we ain't used yet, Griffin?
$5.
What was $5?
The equals the total.
The total of the 2 books together, right? Both books together cost $5. So what's our equation?
X plus 2.50 equals 5.00, which is 5.
We could just say 5. I'm going to go ahead and leave it in the money look for us to here. I think that'll make it easier in the end. Let's combine the x's here, Griffin.
2x.
And at the same time, let's get rid of this plus 250.
Negative 250 on both sides. And
Now cancel here, of course. And what do I get on the other side? What's $5 minus 250?
what?
Uh-oh. Snack cart been taking advantage of somebody.
I'm like kids trying to find it.
Just do it in your head.
Yeah.
Bryson's going crazy. Bryson, 250.
Oh yeah.
$5
Can I
minus
leave?
250 is
Get
250.
break.
It's okay. It's all right. It's Monday brain. All right. So now we got to divide both sides by the 2, and this is why I wanted you to leave it in the money form here. What do we get if we cut 250 in half?
$1.25.
$1.25, right? Because $2 bills and 2 quarters, half of that is a $1 bill and a quarter, right? $1.25. And so apparently, Griffin, what cost $1.25?
The second book.
The second book cost $1.25. Don't forget your dollar sign. The first book cost $2.50 more than that. So if we add $1.25 plus $2.50, Griffin,
$3.75.
there we go, $3.75, and there's our $2 amounts. How many had those 2 amounts for the 2 books on problem 5? Okay, several of you. Those who didn't get it, questions, comments, feedback. Those who did not get it. Does it make sense now if we missed it? Right? Feel like we're how many say, I kind of struggle with some of these, but I feel like I'm starting to get the hang of what we're doing here. It's making a little bit more sense now. All right, questions at all? Let's look at our last one here. Number 6, read that for us, Jalen.
The sum of 2 numbers is 44. One number is 8 more than the other number. Find the number.
All right, once again, how many unknowns, Jalen?
2.
And we're simply trying to find the 2 numbers. And it actually refers to them, if you want to be really literal, it calls them one number and it calls them other number. I mean, if you really want to be really literal about how it describes the numbers here. And what's the comparison sentence here, Jalen?
One number is 8 more than the other number.
All right, so in the comparison, it comes back to what at the end?
Yeah.
The other number. So who gets to be X?
Other number.
The other number. It says, what about the one number? It says it is
8 more.
8 more, so that means one number would be
X plus 8.
X plus 8. Okay, if you want to be really literal about it here. How many had, and technically, you could have just called them first and second number and it really wouldn't matter. At least one of them was X and the other was X plus 8. I'm trying to be really literal here on this one, but you had X and X plus 8 as the unknowns. All right, then it says what about these 2 numbers at the very beginning?
The sum of 2 numbers is 44.
The sum of the 2 numbers is 44, so what's the equation going to be here, Ben?
X equals 4.
It says, what was that first sentence, Ben?
The sum of 2 numbers is 44.
The sum of 2 numbers. What does sum mean?
And
We're going to add these 2 numbers. And if I add these 2 things, it says it is 44. So what should our equation be?
2x plus 8 equals 45.
All right, how many had this equation either initially or maybe you had x plus 8 equals 44, but you got to this point at some point. All right, then what do we need to do, Ben, to finish solving? What do we do now? Want to get x by itself, solve the equation.
8.
What do we do with the 8?
Subtract it.
Subtract the 8 from both sides. Class, that's going to give me 2x is equal to
36.
36. There we go. Then what do we need to do, Ben?
Divide 2.
Divide the 2 from both sides. And when we do, class, we're going to get x is equal to 18. Now again, if we're being really literal, class, which number is 18?
Others.
The other number. So the other number is 18, which means the one number is
26.
26. 8 more than that. And there's our 2 numbers. How many had 26 and 18 as your 2 numbers? All right, questions on those? All right, let's take a look at the bottom section there. This is just stuff that was on the kinds of things that were on your quiz the other day. Number 7, what did you get for your answer, Luciana?
P equals 8.
P equals 8. Number 8, Elaine.
A equals 45.
A equals 45. Number 9, Jalen. X equals -4. Excellent. Number 10, Griffin.
A equals 3.
Oh, Joel. A equals -3. Don't lose that negative. Number 11, back to Griffin for redemption.
X equals 48.
X equals 48. Excellent job. And number 12, Bryson.
R equals 100.
Close. Corey?
Or equals -100.
R equals -100. You lost that negative there. Be careful. All right. Questions on the homework? Yes, sir.
Can you do number 8 then?
Yeah, number 8, we had a 15, so where a over 15 equals negative 6 plus 9. Well, first things first, let's go and simplify the negative 6 plus 9. 3. So it gives us a over 15 is equal to 3. But how do I get the a by itself?
Multiply
By,
15.
there we go. But what we do to one side,
And then
and 3 times 15 is 45. And there's our answer. That make sense? All right, good. Other questions on the homework? Flip back to the previous page and very quickly do the 17 through 19 at the bottom. Very quickly do the 17 through 19 at the bottom. Should take you about 1 minute to do those 3 equations. 17 through 19 at the bottom of the previous page, page 459. Take about 1 minute. All right, Corey, number 17.
8.
X equals 8. Number 18, Ben.
A equals 16.
Excellent job. A equals 16. Number 19, Michael.
X equals negative 7.
X equals negative 7. Great job not losing the negative there. How many of those 3 answers? All correct. All right, let's do a little bit more practice now with word problems. Number 5. Read that out loud for us if you would, Joel.
The sum of two consecutive odd numbers is 52 common numbers.
Ah, okay, class. Anytime we deal with consecutive numbers, the first number should always just be X, because I don't know what it's going to be, right? I don't know what that first number is. It could be anything, so let's just call it X. The next number depends on whether they're just plain old consecutive numbers, or if they're consecutive even or odd, class, we end up counting by 2s. If they're just plain old consecutive numbers, we just count by 1s, right? Plain old consecutive numbers just count by 1s, right? Like 5, 6, 7, 8, 9, 10, so forth, right? Well, this specifically says consecutive odd numbers, which means we have to count by 2s, right? So my first number, again, first number, just let it be X. But my next consecutive odd number, class, has to be
X plus 3.
X plus 2, because we're counting by 2s. Right? We're going to add 2 to whatever the previous number is. So if this number is 11, my next odd number would be
13.
13. If the first odd number is, I don't know, 71, then the next odd number is
73.
73, right? Whatever odd number you start with, add 2 to it, you're going to get the next odd number, right? So then, if it says that the sum of these consecutive odd numbers is 52, what's our equation going to be, Joel?
X plus X plus 2 equals 52.
Let's combine x's, class.
2X.
And let's ditch the 2 as a negative 2.
50.
And so x equals
50.
What?
25. X equals 25. Which means, which of my 2 numbers is 25, class? The first one, the smaller of the 2. The next odd number has to be what, Michael?
27.
27. And there's my 2 consecutive odd numbers. We've done several of these at this point. Do we feel pretty good about the consecutive even and odd stuff? Those are boring anyway. Number 7. Let's go right below number 5. Number 7. Read that for us, Ben.
These bags contain a total of 37 candies. One bag contains 9 more candies than the other bag. Find the number of candies in each bag.
All right. So, how many unknowns do we have here, Ben?
1,
No, Ben.
2,
2. What are the 2 unknowns?
the first bag and the second bag.
The first bag and the second bag. If we wanted to be literal, we call it one bag and other bag, but we can call it first bag and second bag. Ben, which sentence compares these 2 unknowns to each other?
The first one.
Does it compare anything? It gives me information, to be clear, it does. 2 bags contain a total of 37 candies, but that's not really comparing the bags to each other, is it? Which sentence compares the bags to each other?
Second bag.
Read that second sentence again.
One bag contains 9 more candies than the other bag.
Ah, which one does it come back to in the end here, Ben?
The bag.
Which one?
The first one.
Ben, one bag contains 9 more candies than the
Other.
other bag. Assuming that by other bag, we're talking about the second bag, let's let the second bag be X. Or you can do C for candies or B for bag, whatever. But if it says that one bag, meaning the first bag, contains 9 more candies, how would we represent the candies in that first bag?
Plus 9.
X plus 9. Whatever the second bag has in it, plus 9 more than that. Now we come to that first sentence, because the first sentence tells us what about the 2 bags collectively, then.
There's 37 candies in total.
37 candies in total. So what should our equation be here, Ben?
X plus 32. And that's 37.
Well, how many candies are in the first bag, Ben?
Down
It's on the board. How many candies are in the first bag?
X plus 9.
X plus 9. How many candies in the second bag?
X.
X. And total, that's how many candies? According to the word problem. How many candies is that total?
2x plus 9.
I mean, it does add up to 2x plus 9, but how many candies is that total? First sentence.
37.
37. So Ben, when you say, well, the total is 2x plus 9, you're not wrong. But the problem also tells me the total is 37. This is the total, and that's the total. They're both the total. So they must be, class, equal to each other. They're equaling 37. The total of the 2 is or equals 37. And there's our equation. How many had that equation? At your seats, solve. And at your seats, solve that equation. And when we subtract 9 from both sides, divide both sides by 2, what do we get for our answer of x, first of all, here? Joel?
14.
End up getting x equals 14. Okay, so then, if x is 14, which bag has 14 candies in it, class?
X.
The second bag.
The second bag. Okay, the second bag has apparently 14 candies. And that means that the first bag must have 23 candies. When you add 9 plus 14, it's 23. And there's my 2 answers. How many candies in each bag? 23 in the first, 14 in the second. And there's our 37 candies total. Again, I think I saw this reaction from a lot of you. You got here and thought, oh good, I'm done. No, not done when you get x equals. Got to go back and find the actual answers, which is why it's worth your time to show all of those steps, right? Show the 2 unknowns listed out. Show how you represented them. Show your equation. Get your answer, plug it back in. Let's take a look at number 9. Read that for us if you would. Ooh, this is a fun one. A little bit of a blast from the past here. Griffin, read number 9.
The perimeter of a rectangle is 60 units. The rectangle has a length that is twice its width. Find the width and length of the rectangle.
How many unknowns do we have in the problem here, Griffin?
2.
What are they?
Length and width.
Length and width. Now, how does it compare the length and the width here, Griffin?
The rectangle has a length that is twice its width.
Ah, the length is twice its width. So class, who gets to be x?
Width.
The width. Be careful, Griffin. How would we represent the length?
2x.
2x. How many also thinking 2x here? It is twice the width. Now, here's where we got to be careful. To find perimeter, class, do I just add the length and width together?
No.
No. What's the perimeter of a rectangle, class?
LW.
P equals 2 times L plus 2 times W. Do you remember that? P equals 2L plus 2W. So I don't just say add the length and the width and it equals perimeter. No. 2 times the length, class. 2 times 2x plus 2 times the width, or 2 times x. That equals the perimeter. That's why I say blast from the past. We've got to remember a little bit from earlier in the year here, right?
This is
2 lengths plus 2 widths equals the perimeter. Now, what is the perimeter of this rectangle? Ben, stay awake. Stand next to your desk. What is the perimeter of this rectangle? Michael?
60 units.
60 units. Do we see that this equation, class, is not just Add the two things and it equals whatever. We had to put a little more thought in on this one because it's perimeter and we had to remember what that means. Now, if it had been perimeter of a triangle, I'll just add the three sides, right? If it had been perimeter of a square, though, 4s, right? So whatever the length of a side is 4 times that, right? But here it's a rectangle, so 2 lengths plus 2 widths equals. Well, what do you suppose we'd get if we multiplied 2 times 2x?
4x.
What about 2 times x?
2x.
And so 4x plus 2x,
6x.
6x. And now we just divide both sides by, we divide both sides by 6, and suddenly it's not so bad. X just equals, class, 10.
That's easy.
There we go. See? So whining. Okay, so what's the width?
Oh.
20.
The width?
Oh,
10.
5.
even
10 units.
Oh, it's 5.
Class, what's the length?
5.
20.
100.
20 units. 2 times 10 is 20.
Monday morning brain.
Yeah, apparently that's what it is, yeah. All right, questions on this word problem?
No.
Let's take a look at number 11.
Oh.
Read number 11 for us.
Oh my.
Luciana?
Cooper and Amelia have deposited a total of $126 into their savings account. Amelia has saved 5 times as much as Cooper. Find the amount that each has in their savings account.
At your seats, write down the first 2 unknowns. You can do it standing, it's okay. Write down the 2 unknowns. You may want extra paper, by the way, for this. Remember last lesson we had some extra paper out, so get some extra paper out, or you can use the back side of the quiz I handed back to you. There was some room on that. Write down your 2 unknowns. That's all I want you to do for starters. Doesn't require a whole lot of brains to do that, which is nice, especially on a Monday morning, the way this class is going. What did we write down on the paper so far, Luciana?
Cooper and Amelia.
Cooper and Amelia. How many also had Cooper and Amelia written down? Okay, I'm seeing some people crossing things out already. Okay, this is not a good sign. All right, Cooper and Amelia are our 2 unknowns. Now at your seats, find the comparison and pick the right one to be X. And now at your seats, mark which one is going to be X. Just do that much. Find the comparison and mark which one gets to be X. And Luciana, which one is X?
Cooper.
Cooper. How many had Cooper as X? Because it says Amelia's 5 times as much money in her savings account as Cooper. So since it comes back to Cooper, then who gets to be X, class? Cooper. Okay, but now at your seats, represent Amelia. Based on that comparison, represent Amelia. And what did you put for Amelia, Luciana?
5x.
5x. How many had 5x for Amelia? She has saved 5 times as much. Not x plus 5, not 5 more. 5 times as much. So 5x. How many had that? All right, any questions so far? Now, find the unused number, the one you ain't used yet, and write your equation. Now at your seats, write your equation. Now at your seats, write down the equation. You've already used your freebie, so do demerit if you need to go. And what is your equation, Luciana?
X plus 5x equals 126.
How many have the same equation? X plus 5x equals 126 because they have saved a total or deposited a total of $126 into the savings account. Now at your seats, solve and get both answers. At your seats now, solve and get both answers. side, how many of you combined to get a 6x and then divided a 6 on both sides to get x equals 21? Now, who has only, bless their hearts, $21 in the savings account, Luciana? How do you know Cooper only has 21?
Because Amelia has 5 times more than X.
Well, because Cooper's x, and x is 21. So if x is 21 and Cooper has x, then Cooper has 21, right? That's pretty straightforward. How would we find how much Amelia has? How do we find Amelia's total, Michael?
We multiply 5 times 21.
5 times x. Well, x is 21, so 5 times 21 tells me how much does Amelia have. Luciana?
105.
$105 in her savings account. How many have these 2 answers already? Okay, had those 2 answers. Questions on this? Yes, sir.
How'd you get to 6?
Well, because this isn't understood 1, remember, in front of it, so 1x plus 5x is 6x.
I forgot about that.
So you just had 5x equals. You thought no x's plus 5x's is 5x, and then it wasn't dividing. Well, yeah, so remember the understood 1. Anyone else fall into that trap besides Ben and Michael? Luciana as well. Okay, so yeah, be careful. Remember that understood 1 in front of the x. Let's take a look at number 13 right below it. And, read this for us if you would. Number 13, Michael.
15 students are seated in the first three rows of the classroom. Each row has 1 more student seated than the row before it. Find the number of students in each row.
How many unknowns do we have, Michael?
3.
3 this time. We haven't seen 3 in a while. There are 3 unknowns, and the 3 unknowns are the 3
Rows.
the 3 rows, or the number of students in each of those 3 rows. So at your seats, write this down. Row 1, row 2, and row 3. By the way, how many of you at your church have noticed the back of the church is always more full than the front of the church? Yeah, so there's only a few people at the front, and it gets more and more. That's how this classroom is. There are some students on the first row, but there are more students on the second row and even more students on the third row back, okay? And it says that each row has 1 more student than the row before it. Well, you realize, class, that if I knew row 1, I would know row 2, right? If I knew row 2, I would know row 3. The only row that doesn't depend on anything else is row 1, because it's where it all begins. So let's call row 1 X. Because I know that however many students are in row 1, whatever that number is, the next row has 1 more kid in it. So row 2 has
X plus 1.
X plus 1. But then row 3 has 1 more student than the row before it. What would I get if I added 1 to X plus 1?
X plus 2.
X plus 2. Right, X plus 1 plus 1, or X plus 2. Do you see that each row has 1 more than the the row before it? But the number we haven't used yet, Michael.
We haven't used 15 students.
15 students total in those first 3 rows. So what should our equation be, Jalen?
X plus 1 plus X plus 2 equals 15.
There we go. Just add all 3 of those things together. Now, we do need to combine all these x's together, right? I've got an x plus another x class. 3x. I also should combine the constants. 1 plus 2, 3. So we should get it to a 3x plus 3 equals 15. At this point, solve and get your 3 answers. At this point, solve and get your 3 answers. When we subtract 3, we divide 3. We end up getting x class equals 4, but we're not done because that doesn't tell us how many students are in each row. Class, which row has 4 students? The first row, because the first row is x is 4. First row has 4 students. What about row 2, class? 5 students. And row 3? 6 students. And there's our 3 answers. How many have those answers now? Okay, questions on that problem? Bless you. All right, last one for today. Let's look at number 15 here, and let's see. Anyone actually collect football cards? Anyone have a collection of football cards? Michael, you do? Used to. You sold it or trashed it?
I still have them.
Oh, you do still have it. You don't collect them anymore, but you have an old collection. Yeah, I have an old collection from my high school days. Go and read this for us if you would, Michael. Number 15?
Okay. Kevin Mitchell had 538 football cards. Kevin has 126 more than Mitchell. How many football cards does each boy own?
All right, you do this one completely on your own. At your seats, do this completely on your own. You may sit down, yes, to work. What was your question?
Couldn't you just add 538 to 126?
That would not give you the correct answers, no. You need to go through the process. How many of you recognize there's two unknowns? How many realize they were Kevin and Mitchell, or Kevin and Mitch because I'm lazy? How many realize that Mitch had to be, or Mitchell had to be the X? And that Kevin was X plus 126 because he had 126 more than Mitchell. Was your equation then X plus 126, or 2X plus 126 equals 538? Subtract the 126, divide by 2 to begin up getting to X's 206. Then, who has 206 cards, class? Mitchell has 206 football cards. How many does Kevin have?
332.
332 cards. 126 more than Mitch. How many had those two numbers? Okay, question. Do you see now, by the way, why you can't just add 126? In fact, technically you subtract and then divide by 2. But yeah.
I just didn't know which one had X first, so I flipped them.
So you have these two answers, you just put them in the wrong spot. So again, the key you're looking for there is that second sentence where it says that Kevin has 126 more than Mitchell, and whoever's name comes last in the comparison, that's why I say find the comparison sense. The last thing to be mentioned in the comparison, that's your X. And then the other one becomes, in this case, the X plus 126. Good question. Good. Other questions, comments on word problems? Do we feel better about them now than we did before? All right. Homework for this evening, you're going to practice with just a few of these as well as some other equations as well. Page 466. Page 466, do the review 34 to 41. Page 466, do the review 34 to 41. We'll take a look at these tomorrow. Have a wonderful rest of your day. And when the bell rings, you are dismissed.